This
Talk about the EBS Elastic Block Store. Okay, so EBS is also part of EC2. So today we'll see introduction to the EBS, EBS size and capacity, and what are the benefits of EBS. In what scenarios we use these EBS volumes. We have different types of volumes are available, and we can take snapshots of EBS volumes, and we'll see what is the pricing of EBS. Okay, there is a difference between instance store backed instances and EBS backed instances, and finally we'll see practical. Okay, so before we go and talk to the EBS, let us discuss about the storage in the traditional data center. Then you can easily understand what is the purpose of EBS. Okay, see, if you see in the traditional data center, we have a lot of servers. Maybe depend upon your project, you may have 500 servers, 1000 servers, or maybe 200. Okay, so we have some around 50 to 100 physical servers. Okay, now all these physical servers are going to have only 100 to 200 GB hard disk, internal hard disk. Okay, so if you have 200 or 100 GB internal hard disk, then those hard disks also we are going to use it for the operating system. Okay, so if we are using the existing hard disk for the operating system, then where we are going to install our applications or databases? Where we will install? So we are going to have in real time external storage. Okay, so this will be existing hard disk is going to be used by the operating system, whatever it's a Linux or Windows or whatever it may be, and we are going to add storage, okay, through external. Kana, can you please go mute?
Yes.
So here we are going to have a storage box, and this storage box will have multiple hard disks will be available. Okay, okay, so this storage box is going to be connected to this hardware. Okay, it will be like these machines are going to have HBA cards. Okay, like our LAN card, same way your server contains HBA cards. So it is going to be connected. Actually, there will be a switch will be there this way. Two switches will be there, and the switch will connect to the storage box, and the switch contains ports. So one switch will connect to here. Okay, so the other will connect here this way for the redundancy purpose. Okay, so two HB cards for redundancy. One cable will connect to one switch, another cable will connect to another switch, because they should not. For example, in case if something happens to this switch, then if you have only single switch, then all your servers are not going to work. So from this storage box, okay, there will be separate storage team in your environment. They are going to allocate storage volumes to each and every machine, whether you want 100 GB, 200 GB, 300 GB. So logically through these cables you can able to see storage under this servers. It looks like physical, okay, but it's logically available from the server, but physically the storage will be available here. Okay, so whenever you want, we'll should ask the storage guys, so they will allocate through these cables, and we can create partitions. For example, with Windows machine, we'll create D drive, E drive, F drive, what the partitions you want to create. And in future, whenever you want to extend, okay, if you want to extend D drive, E drive, F drive, then again you can ask them. They can add more volumes to your server, and by using that volumes you can extend your partitions. Okay. In the Linux, in the Unix flavors, we have an LVM concept, logical volume manager concept. Okay. So with this existing volumes, we can logical volume manager. Okay, we can create LVM, and with the help of LVM, we can create volumes, and we can install applications inside that. So to maintain the SAN switches, the storage box, we have separate team will be available in the traditional data center. Okay. The same thing now we are going to talk about this EBS volumes in the data center. Okay, here now let's say this is AWS environment. Let's say this is one availability zone, this is another availability zone, and we have a lot of servers here available. Okay, these are physical servers. From this, we are getting some shared resources whenever we are creating. So, whenever I am creating a server, okay, I am going to get only compute resources, means maybe whatever I'm expecting CPU 16 GB, RAM something like 32 GB. This is the capacity I'm expecting. But what about the storage? To load your AMI operating system and to install your applications, where is the storage? So at the time of creating instance, we got one option, okay, attach 8 GB volume. So from where it is getting? This volume is also getting from here also in the AWS data center. We have a storage. Okay, same like this, we'll have a storage. With this storage, we are allocating 8 GB of storage to your hardware so that what are the AMI you got selected. Okay, again it depends upon the type of operating system you selected. If you select Windows operating system, automatically, let me show you by logging in. If you select Windows operating system, it will select 30 GB by default. If you select Red Hat operating system, Red Hat operating system with 10 GB. Okay, so for Amazon Linux, it is taking 8 GB. Quickly, let me create one instance. Will not create. I will stop at EBS option. Launch instance. See, if I select Windows, okay, let me select Windows. Okay, the Windows operating system, whatever I selected, to load that operating system, I cannot use this T2.micro. This hardware is not sufficient. Let me go and select, because it's a SQL server with Windows. I don't want SQL server. Okay, base operating system will select. Now we got this one. By default, select this. If you see, this is EBS storage. So by default, it's allocating 30 GB of volume. From where? From this storage box separately. There is no internal storage. You are getting from this server only hardware capacity, but storage you are going to get from this storage box. Okay, 30 GB you are getting. And let me select once again, choose AMI. If I select Red Hat operating system, it will take 10 GB. So again, I'll take T2.micro. This is network details default. And if you see, this is 10 GB. So for Red Hat operating system, it needs 10 GB of volume. Okay. And if I select Amazon Linux, same T2.micro, default details, and this is 8 GB. So it depends upon the operating system. So how much storage it should be allocated, it will decide automatically. But you are getting these volumes from this particular storage box. Okay, so this is 8 GB is only for the operating system. As of now, we are using only 8 GB for the operating system. What are the AMI we selected? To load that AMI, we are adding this external storage. After creating the instance, depend upon the requirement. Application team or database team, whoever raised request. First of all, why we create instance? If we get request, then only we'll create. Someone requested that we want to run some applications, okay, then only they will raise a request that we want this type of instance. They will itself tell that they want t2.nano, t2.micro, or m5.large. Okay, we are not going to decide what kind of instance they are expecting. Okay, so their applications databases to run, they will come up with what kind of server they want, how many partitions should be created inside that. Okay, and what should be the size of that, naming convention, everything will be provided by them. So as AWS administrator, we need to launch, create that instance, and we need to allocate those many storage volumes to that server, and we need to create partitions. As I said, in Windows, you need to create D drive, E drive. If it is Linux, then you need to create multiple partitions. Okay, so that they can come and log in and they can install their applications. Okay, so later on, you will decide how much volumes you are going to allocate. And today we are going to see how to create these volumes and how to attach to this instance. And after attaching, how to create partitions inside the operating system. Okay. So how to create partitions and how to extend this volume. If I created a partition, for example, I allocated some 30 GB volume from here. Okay. So to this machine. So with this 30 GB, I created a partition. Now after 3 months, it is reached around 90% usage. Then again, I want to extend. How to extend it, and how to take the snapshot of this particular volume, and how to restore that snapshot. All these things we'll discuss now. Okay, and some famous companies are providing these storage boxes like EMC, IBM, Hitachi, 3PAR. These are the famous companies who are providing this storage. Right now, EMC is actually it's a EMC Dell. Recently, I think 1 year ago, Dell has been acquired this EMC company. Okay, now let me show you how this box looks like. Okay, if you see, these are the hard disks. These are hot swappable, means we can pull this hard disk without any downtime also. Okay, so these are all the hard disks. So the storage guys will maintain this storage box. So now in the cloud, we don't need to have any storage guys. Even kids can also play with these EBS volumes. Okay, we no need any high-end knowledge, technical knowledge on the storage. But in the traditional data center, we used to have separate storage team to maintain the storage boxes and SAN switches. Okay, but by clicking on EBS, we can create volumes and we can allocate to the instances. Backend AWS is going to take care everything, the storage volumes, okay, and the physical setup, everything. Front end, by doing multiple clicks, we can create volumes in a very simple way. Okay, now let's go back to the. Now you got idea, right? What is the purpose of this EBS? EBS here it's a front end service name. Backend, maybe even AWS also might be using EMC storage or maybe Hitachi 3PAR. We are not sure, but they might be using any of the popular product. So today also our discussion will be how to create this volumes, how to attach to the instances, and from the instance, how to create partitions, okay, and how to extend that, and how to take the backups and how to restore it. These are the things we are going to discuss. And we have different types of storage also. Okay. So EBS volumes are persistent storage volumes to Amazon EC2 instance that can be attached to running instance. EBS volumes is automatically replicated within its availability zone to protect you from common failure, offering high availability and durability. What AWS is doing, whenever you take any volume, by default, Let's say I allocated this as a 30 GB. Okay, so this is 30 GB volume. Whenever I create this volume and attaching to the instance, backend they replicate this volume. Okay, replicate means whatever the data is coming to this volume, they'll create another 30 GB volume, and whatever the data is coming inside this volume will be replicated to the another volume. This is taken care by the AWS. Okay, we no need to raise any special request, or we no need to tell them before, and nothing from our side. Just we create the volume and we are practicing ourselves, but back end they create replica of this volume and they will keep a handy. Okay, this is for high durability and high availability. In case something happens to this volume, you can ask them. Okay, you can request them, like you need to raise a request like ticket, or you can make a call so that they can give you the volume which was replicated. Replicated means whatever the data is coming to this volume will be replicated to the same to the another volume. So you can scale your usage up or down within minutes. Scale your usage means based upon your usage. If you need more storage, then you can increase your capacity. Suppose I created 100 GB volume, but we are from last 2 months onwards, we are using only 10 GB after that. You can reduce also. Why I should waste unnecessary 90 GB of volume data? Because AWS is charging us, right? Unnecessarily, if you are taking this much of storage, then backend they are charging for this 90 GB also. So which is not at all use. Instead of that, I can reduce it to the 50 GB also. Okay. So here AWS is giving you 30 GB of EBS volumes. Okay. For your free tier account, see, always remember here free tier account means not everything is free. In EC2 already I told you only T2.micro instance is free, and that too 750 hours. There is limitations for everything. It doesn't mean that 12 what we say 12 months of free account, in the sense it's not like whatever you want you can create. There is a limitation. So even storage also you can use up to 30 GB. That is enough for us for our practical. Okay, maximum always we will create one or two servers, will practice and will close them. We don't want we are not installing any applications, right? Any high-end applications to need more storage. So for our AWS post practice, 30 GB is more than enough to practice. Okay, so we can create maximum up to 16 TB of volume. The volume size can be up to 16 TB. We can create a single volume. Okay, so we can also create Amazon EBS general purpose solid state drive volume that can be stored up to 16 TB and process up to 10,000 IOPS. So these volumes are designed for 5 nines of availability and up to 320 Mbps second of throughput when attached to EBS optimized instances. So here in the storage terminology, one thing you need to remember is IOPS and throughput. Okay, so IOPS and throughput, these are the storage terminology. Okay, IOPS measures the number of read and write operations per second, while throughput measures the number of bits read or written per second. Okay, let's say I hope everyone knows the bank called ICICI Bank. Okay, now most of the companies, for example, most of the companies using ICICI Bank as a salary account. Now, on the first of every month, once the salary has been credited, maybe all over the India, at a time, okay, at a time, for example, 4,000 members are trying to access it. Okay, so during that time, 4,000 members are trying to access, maybe try to log into the ICICI website so that they can transfer funds to someone else, or they want to check the salary whether how much they credited. Okay, so everyone is trying to log in, like around 4 to 5,000 members are on that particular time logging. So whenever that 4 to 5,000 persons are logging in the same time, backend your server wherever your application is hosted, basically where it is hosted. Okay, CPU RAM is separate. See, whenever your server is performing slow, like whenever I'm accessing an app, if it is not performing properly, there might be four reasons. One is your CPU is not sufficient wherever that website or app is hosted, or maybe your RAM is almost full, or maybe network issues. Your network bandwidth, the LAN card, whatever the network is coming, that is also not enough capable to handle that much of load. And final thing is backend your hard disk, because in your hard disk, this storage volume itself, your application or your database is hosted. So if all of a sudden 4,000 requests are coming to you, whether it's a read access or write access, what is read and write? Read means, let's say if I log into my website, I'm just checking the balance statement, that is called as read action. But if I'm doing transaction, if I'm transferring some money to someone else, that is called as a write access. Means write means what? Something has been modified in your account. Something has been modified. So backend wherever this database is available, okay, from that table, database table, it has been modified that previously you have 1 lakh rupees, now you transfer 10,000. Now balance is 90,000. Some modification has been done, right? But if you are just going and checking the statement and balance and logging out, that is called as a read transaction. So whether read or write transactions, all of a sudden 4,000 transactions are coming, like 4,000 requests are coming. Your hard disk should be capable of handling those many requests. Okay. So immediately on that particular second, for everyone without any issues, everyone should able to log in. Okay. So how it is possible? It is possible only if your storage is having enough IOPS. So whenever you're allocating storage, so how much IOPS you want should be decided. Okay. So for example, if I started an app, it's a startup company just now recently started. Obviously, for my app, very less requests will come, right? Input output transactions will be very, very less because it's not become famous. Recently, yesterday, day before yesterday, I was trying to book tickets on Book My Show. Okay. But whenever I'm trying to book on that particular time, it's giving some error because maybe there are a lot of requests are coming and that app maybe could not able to handle those many requests. Okay. So your storage is very, very important for the performance wise. So if lot of users are falling on your site, previously maybe in 2009, 2010, whenever the Flipkart was also announcing sale, at that time we used to get lot of issues. Like whenever we are trying to access it on the sale day, especially on the sale day, I tried so many times, but I never purchased anything on the sale day because it will keep on scrolling, 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 and again it will tell item is sold out. Okay. So why? Because due to insufficient IOPS for your storage capacity, it is not accepting those many requests. If you have two hands, if two people are coming to you, you want to serve something, so immediately you can serve. But if three or four people are coming, it will take some time until unless the two people is completed, you can serve for the remaining two people, right? Same way IOPS, if you have storage enough IOPS, then whatever the requests are coming, it can provide that request immediately. Okay. So again, this is depends upon your application outside. You'll have the records, right? Daily, how many users are acting at a time, at that particular time I'm talking. This is per second we are talking about. So how many requests are coming? Okay, based on that, we'll allocate IOPS to your storage. Okay. And throughput is for data transfer. So mostly throughput and IOPS is not used for same application because depends upon how your application is functioning, your website or app. Okay. So if it is, for example, any streaming one, then we use more throughput value. We don't need any IOPS. But whenever we are, just now I said like Book My Show, Flipkart kind of stuff, lot of people are accessing, then you need IOPS. Maximum 90%. we don't need both for a single server, single volumes, because the application, whatever is accessing front end, depends upon that we will select this application, this website need IOPS or throughput. Okay. So data transfer speed will be very high if you want to give more data transfer. So here you can give select maximum you can give 320 Mbps of speed second per second, 320 Mbps second of throughput when attached EBS optimized instances. Okay, so this is some storage terminology. Only this is the only thing you need to understand. Remaining everything is very simple. This is the storage terminology, and backend we are the storage whatever we are allocating. It's called as an SSD volumes. Okay, solid state drive volumes, which is very high end. Okay, generally in the hard disk we have different types of hard disk will be there. Whatever the hard disk we get for our laptop, it's a very basic hardware. But just now I shown you that EMC storage, those hard disks are very costly and it will be crores of rupees because the technology what I'm using for this hard disk, because lot of from different places different requests are coming to access your website or app, so your hard disk is also very enough capable, should handle those many requests and it should not give any kind of performance issues. For that purpose we use SSD drives, solid state drive, which is very costly hard disk we use. Okay, that's why you'll get this kind of features inside that hard disk. And where we use this storage volumes, basically for application servers we create EC2 instances and we create volumes and we allocate to that servers, or maybe database servers. Okay, we have separate class called RDS service. In the RDS service also we are going to create these volumes, and because database means what, data is coming where it is going to store in the EBS volumes itself. So we use this EBS volumes for the databases and especially in the EC2 whenever we create application servers. Whenever you are creating volumes, it will ask you three types of volumes are available. Which type of volume you want to create? Okay, general purpose, provision IOPS, and magnetic. General purpose, and this 30 GB whatever they are giving free for our free tier account, you can use any type of volume. You can go with the provision IOPS, general purpose, or magnetic. It's not specific to any separate category, so you can use that 30 GB for any type of volume. Now the difference between general purpose and provision IPS, both are SSD drives. Basically both are SSD drives, but we don't use general purpose for the production environment. Why? Because in the general purpose, whenever I create volumes, I don't get option to provide these many IOPS to that particular volume. Let's say if I'm creating 100 GB volume, for 100 GB volume, I want 1000 IOPS. I cannot allocate in that way. By default, it will allocate based upon the size whatever you selected. For 100 GB, you are going to get only 30 IOPS or I think 300 IOPS. Okay, I think 300 IOPS will get. So I want 1000 APS or maybe 2000 APS. I cannot allocate. Based upon the size of your volume, automatically AWS will allocate these many volumes. So basically we use this for the development purpose. Okay, because development servers, no one is coming and accessing your development server, right? So no one will come and access. Only in the testing phase, development phase, only we are guys are accessing and will see how the functioning is happening of that application, website or app. Okay, so general purpose is used for the development purpose. And provision, name itself telling provision IOPS means you can provision even for 100 GB, you can provision 1000 IOPS also. So depends upon the request, you can provision more IOPS. So we use provision IOPS for the production environment. Magnetic. This is not an SSD drive, so cheaper than the SSD, and it does not contain any IOPS also. We use any unwanted servers, which is like POC kind of stuff is there, then we use this magnetic volumes to that instances, any test servers, even not for development also, even test server. Okay, for them we will use this magnetic volumes. So general purpose will use for small to medium sized databases development and test environments. Okay. So per GB, 3 IOPS. That is what I said. If you allocate 100 GB volume, then you will get automatically 300. You don't have option to modify over there. Okay. Based upon the size. Provisioned IOPS and suitable for application with IO intensive workloads. Okay. So if you are getting lot of IO requests, you need more IOs, then you need to use provisioned IOPS. Okay, 30 IOPS per GB to a maximum of 20,000 IOPS and provide up to 320 Mbps of throughput per volume. So you'll get very good performance, and this is the default values. If you don't want this much, if you want more also, you need to raise a request with the AWS so that they will increase more capacity also. Okay, IOPS or maybe throughput. If your volume doesn't have, okay, could not able to manage with these IPOs, then you can raise a request with the AWS so that they can increase more. Okay. And coming to the CBS volumes, magnetic volumes for the lowest cost per GB all EBS volumes. Magnetic volumes are backed up by magnetic drives and are ideal for infrequent data access and for low storage costs. So infrequent data access means you can understand, right? We are not regularly accessing that. Maybe what are the application or the testing purpose we used it. Maybe not regularly, frequently we are going to access it. And instead of going with the general purpose, you can go with this so that the cost price is also very, very less. Coming to the snapshot, you can back up the data on your EBS volumes to S3 by taking point in time snapshots. So here, this is one type of storage. Okay, we have other storage also. So this is not an high-end storage. Okay, we AWS named it as an S3 as a service, but backend they might be using some storage company. Okay, here. So whenever I take the backup of this, for example, 30 GB volume, this is a backup. So this backup, where it is going to store? This backup, it is going to store inside this storage. This is called, from the AWS terminology, we call it as an S3. S3 is simple storage service. Why it is storing in separate storage? Because I don't want to store my backup inside this storage box because this is a costly storage. Okay, SSD drives are very, very costly. Again, just for the backup purpose, I don't want to store it because backup we don't know when we are going to use. Right? For that purpose, I don't want to waste unnecessary costly storage. So in the real time, we have separate storage called S3, which is not an SSD drives. Okay, same like magnetic drives of kind of storage will be available inside this S3. So whenever we take backup of the volume, it will go and store inside that backup image or what are the backup file will be stored inside the S3. And what it says, taking point in time snapshots. Point in time snapshots means whenever I'm taking the backup till that time, whatever the data was there in this volume, for example, 30 GB volume, maybe 20 GB has been used. Till that time, whatever the data has been available in that volume, it is going to take that backup. That is called point in time. At that point, whatever the data is there, it will take that backup. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshot are saved. Is anyone from the infrastructure background? Any of you?
Yeah, Praveen, I am from DVT.
Okay. Anyone else from the infrastructure background, like backup team, storage team, Linux team, Windows team, database team? Okay, no issues. So snapshots are incremental backups. Incremental backup means, for that let me explain a diagram. Okay, if you see this scenario, we have a volume 10 GB of volume. Today is the first day we are taking the backup. Means 10 GB data is there. The first day, whenever we are taking snapshot, 10 GB data is there. In the snapshot also we can see complete 10 GB of data in the snap A. Today is the first day. On second day, okay, from this 10 GB, 4 GB data has been modified. Data has been modified means what? Here, how it will get modified? Any idea? Data has been modified means just now I told you, whenever if someone logging into their website or Flipkart or bank details and they are purchasing something, means backend data has been changed, right? The files, whatever is there, it is going to be modified. Read transactions means only they are coming and going is called as a read transaction. But if they purchase, for example, you log into the Flipkart and you purchase a mobile, so there is some transaction happened, that information should be updated in the background. That is called write operations, right? So same way here also, whatever the purpose of this application, this volume is using for application, there may be some transactions happen. So among these 10 GB, some 4 GB data has been modified. Existing data itself modified. So second day, whenever you're taking Snap B, it will not take the complete 10 GB once again. It will take only modified data. Okay, from the last snapshot till today, whatever the data has been modified, it will take only that data into the snapshot. Okay, so this 4 GB has been modified from yesterday. So only in the Snap B, it was going to have 4 GB. Okay, and coming to the day 3, 2 GB new data has been added. Okay, this is as it is, only 2 GB new data has been added. Then in Snapseed, whenever you're taking, you are going to get only this 2 GB. So here, whether any data is modified or any new data has been updated, new data has been arrived into the volume, only those things will be taken as a backup snapshot. Okay, this is called as an incremental backup. What are the changes has been done from your last backup? Only those changes, whether it's a new data or existing data modified, anything will be taken as a backup. Why? Because why unnecessary I need to waste my storage? Always if I'm taking 10 GB, 10 GB, 10 GB, you are wasting lot of storage here, because in the first snap it's already available everything. Okay, so next time onwards only modified data is going to take the into the snapshots. So you can save lot of storage here. Okay, and why we take snapshots, as I told, in case if something happens to your volume, this volume maybe from the data center level something happened, or someone deleted, human error, someone is trying to delete files from some other location, but they executed command in wrong place, rmf in the Linux, so it got deleted application data, or it got corrupted. Okay, so if you want to restore, from where you will get it? From this backup. From this snapshot you can restore to the volume. Okay, so that is the purpose of snapshot. So the main advantage is if you access a piece of data that hasn't been loaded yet, the volume immediately downloads the requested data from S3 and then continues loading the rest of the volume data in the background. Means, as I said, something happens to this volume. Okay, maybe corrupted or volume is having any problem. So what we are going to do? We are going to create another volume. Okay, and we are going to restore from this back up to this new volume. We are not going to restore to the existing volume because we are not sure what is the problem with this volume. So again, I don't want to take risk by restoring it to here. So I am going to create a new volume. I will restore here the complete data. Okay, if because this is in the storage, this one, and this volume is here. If it is 100 GB, it may take 3 to 4 hours of time to restore. It is not going to possible immediately to restore it within 5 minutes. It will take compulsory some time. So whenever the restore is happening from this storage to this storage, data should be copied to this volume, right? So it will take around 3 to 4 hours of time. Till 3 to 4 hours of time, do you think my application should be down? No need. Basically, in real-time traditional data center, compulsory until unless backup team restore the data to the servers, we cannot start. Application team cannot start application. Database team cannot start the database. But here you can start it. Okay, so you can start it, and front end maybe from the internet. Any users are trying to access some piece of data which is not been loaded yet to your volume. Let's say if you take rummycircle.com. Okay, in the rummycircle.com we have a lot of options. Let's say I want to check my balance, how much is available. Whenever I click on that, that balance related content is not being loaded yet to your volume, which is not available here. Still it is trying to uh, what we say, restore. Still it is trying to restore to the volume. So what it will do, if the front-end users are trying to access something and if that information is not available in the volume, back-end first it will take that particular information and it will provide it to the users, and then parallelly it is going to copy the data, restore the data from the snapshot to the volume. So both the things it will do. So in this case, you no need to wait for 4 to 5 hours until your data has been restored. You can start your applications immediately itself. You understand? If you access a piece of data that hasn't been loaded yet, the volume immediately downloads the requested data from S3 and then continues loading the rest of the volume's data in the background. So it's very, very good advantage because we can avoid lot of downtime instead of sitting idle. Okay. The key features of EBS snapshots. We're talking about snapshots, and not only the snapshot, the EBS volumes. First thing just now we discussed immediate access to EBS volume data. Okay, so immediately you can access. As I said, when restoring, you don't need to wait until everything is restored to your volume. And resizing means you can increase and decrease the size of a volume. Okay, if your growth is high, what are the file systems partitions you created, immediately the data is falling inside that, lot of users are accessing, so backend your storage is filling, then you need to increase more volumes. Okay, so you need to increase the capacity of the existing volume and we can decrease the capacity. Increasing the capacity is easy, but decreasing the capacity is not that much easy like increasing. Okay, we have another step. Directly we cannot go and increase it. If you do in that way, the data will corrupt. First of all, Amazon will not allow to decrease the capacity directly. Okay, we have one method, we need to follow that. Sharing Amazon EBS snapshots. Snapshots share ability make it easy for you to share data with your coworkers or others in the AWS community. You can give these snapshots and you can upload into the community. Someone else also can use it. Or else the down, if you see, copying EBS snapshots across AWS regions from one region to another region. Okay, this is for more high availability. Basically, we have two availability zones like this. Okay, if I create a server, this is a server, this is a server. Two servers are for same application. So obviously volume is getting from here. For this volume will get it from here. This is more high availability. If something happens to this availability zone, this server will not work, but still my application is up and running. This is my application server running. But what happen if completely this region is having any problem? Then both the servers having problem, right? So that's why if you want, you can take these snapshots and copy to different region. Okay, so if you copy to different region, then ability to copy snapshots across AWS regions makes it easier to leverage multiple AWS regions for geographical expansion, data center migration, and disaster recovery. For data center migration also it will help, or disaster recovery. If something completely region is having any problem, you can start your business because your this volumes backups is available inside the snapshots is available inside the different region. Okay, and I think you guys watched 2012 movie, English movie, that where they will prepare one very big ship, right? So whoever having lot of money, they will go into the ship. That is called disaster recovery. If everything is collapsing, the whoever the rich guys are going into that ship. Okay, so same way, disaster requirements, if something happens, you should start your business from other region. So if your volumes is available in some other region, then you can start your business from there. Just create server, attach those volumes, and then you can start your servers from the different region also. Okay. The price, as I said, always remember if you are taking one server, let's say T2 dot small. T2 dot small is $1. It will be not the same in all the regions. Okay, we have 16 regions, right? In this 16 region, the prices will be cheaper in the North Virginia region. Okay, so the prices will be cheaper for North Virginia region and costly in the Mumbai region, and remaining are vice versa. But among all these, cheaper is North Virginia and costlier is Mumbai. Okay, so the prices will be vary, not huge, slightly it will be vary, because based upon the legal procedure, okay, in that particular country, dealing with the government taxes, all these things, based on that they will charge you. Okay, so the prices will be vary, and it's will be very cheap even if you are using SSD drives also. We have instant store backed instances and EBS backed instances. These are the two different types are available. Okay, EBS backed instances means the instances you are going to get storage from the EBS. The concept is this one. This is the instance. From the storage box we are getting external storage and attaching to this instance. Okay, this is called as a EBS backed instances that use Amazon EBS for the root device automatically have an EBS volume attached. When you launch an EBS backed instance, we create EBS volume for each EBS snapshot referenced by the AMI you use. Okay, so this is externally storage we are adding. And coming to the instance store, instances that use instance store for the root device automatically have instance store volumes available, with one serving as the root device volume with an instance is launched. Let me show you the difference. Where is AWS? I think this one. Okay. Let's say I'm selecting AMI. Okay, these are the instances, right? If you see here, instant storage EBS only, and if you keep on scroll down, if you see, you are getting some internal hard disk. I told you initially, you will not get any internal storage for your server. You need to get it from the EBS volumes. Okay, you will get only capacity, compute capacity you will get, but storage capacity you need to get, it's a external. But we have few instances which also get internal storage, which means what, from this machine, whenever we are, let's say this is a physical box, from this I created a one EC2 instance. So I got CPU 16 CPUs, RAM 32 GB, and 4 into 500 GB hard disk. Also I'm going to get from this internal. This is called internal. Okay, so you are going to get compute capacity and internal storage along from this server. And this one is, you are not getting any storage, you are getting only compute capacity. Storage is using external. This is called EBS backed instances. This is called instant stored instances. Okay, so if you see, some only few instances will be there, and this one. Okay, and if you scroll down, these are the some instances, and these storage devices are more costlier, more powerful than this EBS volume. Some applications need more powerful storage in the background, so those kind of applications need this kind of hard disk. That's why we don't allocate EBS volume, because these are powerful than EBS volumes. EBS also SSD drives, but performance wise it will give more good performance. So some applications need this kind of hard disk. So at that time we will select these instances. Okay, if I select for example 24 into 2028, sorry 2048, means 2 TB volumes, I am going to get 24 volumes storage optimized, means very top level. These are very good performance you are going to get. Okay, let's say I'll select this one 8 and instant details. See, these are 0 1 2 3 internal storage. Okay, so you cannot modify the size of this. You are going to get default 800 GB hard disk, 8 hard disk will come. And for your operating system, you can see again EBS volume, because they don't want to waste this hard disk for the operating system purpose. For 800 GB among from this, they don't want to use 8 GB for operating system. So for operating system, they're using EBS volume itself. And then what are the option we have? 8 GB, 8 hard disk with 800 GB, you can see. Apart from this, again you can add EBS volumes also if you want in case. But if you don't want, you can create partitions with this size and you can use it. Okay, so that is the difference between instant store backed instances and EBS backed instances. So in the lab, we create instance, and what I do, let me come back again. Let me select this one. I'm selecting t2.micro. I'm selecting normal instance itself, retire instance, configure instance details. It is asking, you selected previously something else and now you are selecting something else. Do you want to go back and change the setting? Yes. And this is the networking details by default. Add storage. Here you can add volume here itself, more volumes. Okay, so if you want 100 GB, you can give, sorry, here 100 GB you can give, 200 GB you can give, whatever the size you want you can give, but it's chargeable for you as a, because I said only 30 GB is free. You can give more volumes also. Okay, as of now I don't create any extra volumes. Let it me go with the default 8 GB volume. Next, add tags. You can give any tags to this volume. Mm, test wall, or maybe OS wall. This is a OS related image going to be loaded, so that's why I'm giving OS. Security groups depends upon your requirement, what kind of ports you want to allow. Yesterday itself we discussed this. Review, launch. So let me select the key here. Now let me go and log into that server. Copy the public IP. So easy to use it. See, whenever you select the image, based on that you'll get the easy to user. Okay. If you want to know, see, if you are selecting Amazon Linux AMI, you'll get easy to user. If you select Ubuntu, you'll get Ubuntu user. Okay. Red Hat also will have easy to hyphen user. So different images will have different. If you are using Bitnami images, you'll have Bitnami user. Okay. So these are the different users are available. Okay. Now I logged into this machine. Appearance. The command is lsblk is a command to see list of block devices. Okay. So we have seen xvda, one device which has been allocated 8 GB. From that, it's created one partition and it's named it as an XVDA1 and used complete 8 GB of this volume and it's created as a partition. Okay, so this is for the operating system purpose. And if you see dffnh command, dffnh command is like your my computer. What you can see how many volumes are there, how much space is there, how much is available, how much is utilized. Same way, only single partition is there, and the total almost 8 GB, used is 1.1 GB. See, whenever I was creating instance, it recommended me 8 GB volume, but operating system took only 1.1 GB. Still 6 GB is available, but still we should go with 8 GB only. We should not reduce the space over there. Okay, that is recommendation. So now tomorrow what we are going to see, I'm going to create more volumes and I'll see if I'll attach those volumes to the server. Okay, and once that volumes are available from the server level, I'll create partitions in this Linux machine. How to create partitions? Once I create partitions, I'll store something inside it and I'll try to delete it and I'll will feel like okay something has been deleted, so how to restore it. Before that we'll take snapshot and we'll see how to restore the snapshot, and also we see how to extend the existing volume, the size. Okay, we'll see those things tomorrow practical. If you have any doubts in today's session, you can go ahead and ask me. Yeah, Bhargav, tell me.